clarify what I think is really important for this, because I feel like if you can memorize this chart and use this chart, this is going to be at least 20 questions on the lecture part, okay? So just when you get the sympathetic division, understand, first off, understand location. Location, okay? This one will be T1 through L2. Actually, I think it's through L3, but she has T1 through L2. It can be called name. It can be pre or para vertebral. Pre or para vertebral. And what it's talking about is the location of the ganglia. When you hear the word ganglia, just think bundle. It's a bundle of nerves. It's a big mess. It's like a bulge, okay? It's not flush, okay? Pre or paravertebral, ganglia. Understand they're going to be inverse from each other, sympathetic and parasympathetic, as far as the pre and post. So you have pre and post. So when you hear pre and post, what we're talking about is the actual fibers, the actual ganglia fibers, the nerves. So the pre in the sympathetic are going to be what? Short, right? All right, short? Yeah, short. And then the post is going to be long. The way I remember this, or the way I think about this, is basically this has a longer way to go to get to the effector. The effector is going to, remember this term, effector, because an effector can be what? It's what these nerves are sending messages to do. So these nerves carry a lot of action potentials, which you'll need to know for physio. They carry impulses and things, just information, right? So if a bee lands on my arm, you know, my somatic response is to smack that away, right? It's what I need to do, right? Okay? Well, in order for that to happen, the pre is going to be short in this particular case, right? And the post, it has a lot longer to travel for me to make that connection, for me to make that decision to move my arm and turn my body to move this way and do all that. That's the way I kind of think about it. Okay, so in the sympathetic division, the pre-ganglion fibers are going to be short, but the post is going to be long. So it has a long way to go. So if, I don't want to get too much detail here, but let's say your osmotic pressure is off in your kidneys, right? So the pre is short, but it's got to go a long way to your kidneys to do what it needs to do so it can send ADH to that area to help kind of reduce that osmotic pressure. Make sense? It's just got more work to do. At least that's the way I look at it. This one is going to be location S2 to S4. And then, why do I want to say that there's also, yeah. Oh, yeah, and then just know for sure you're going to have cranial nerves 3, 7, 9, and 10. Which makes the naming part a lot easier for this one. It's literally just called craniosacral. Craniosacral. Again, it's talking about ganglia. Okay? So examples that you might see on your lecture portion. It'll say, which nervous system? This is why you have to really know the two. You need to know, okay, so last week you learned the brain. And you kind of learned a little bit about just the CNS, right? Information's received, information goes out. That's the CNS. Okay, but then it breaks down. And when it breaks down, you have this new nervous system, this other nervous system called the peripheral nervous system, the PNS. Okay, under the umbrella of the PNS, you're going to have the afferent division. This is stuff that information that's coming in, whether it's visceral or motor or somatic. It's coming in, right? And then you have, what are we going to do about it? That's the response. That's the efferent division. So under the peripheral nervous system, you have an afferent division and an efferent division. After the efferent, this is what we're going to do about it. So the efferent can be one of two things. The efferent can be the sympathetic division or it could be the parasympathetic division. Okay? It can only be those two things. Now, before that though, the efferent breaks down. We have to decide, under the peripheral nervous system, we have to decide, is this a motor function? If it's motor, what's it going to be? Which division? It won't be either of these. Somatic. Motor, somatic, same thing, interchangeable. Remember those together. You hear the word motor, you hear the word somatic, they're the same thing. Autonomic, visceral, same thing. Autonomic, visceral, interchangeable. Okay? Now, you wouldn't call the autonomic, I wouldn't call the autonomic nervous system the visceral nervous system, but just know that it's just not controlled. You don't have any control over it. Okay? Under the, so you have the motor, we just decided. Under the efferent division, if it's motor, we decided it's somatic, right? Okay? Which is going to, what's the effector going to be if it's a somatic response? It's only going to be one thing. What causes movement for us? Skeletal muscles. Somatic will only deal with skeletal muscles. So the somatic nervous system uses motor neurons to encourage the movement of our skeletal muscles. That's it. Somatic division, somatic nervous system, very easy. Straightforward. It's using motor neurons, and the effector is skeletal muscles. Under the autonomic nervous system, this is where you have the umbrella. So here, autonomic nervous system, right? You have sympathetic and you have parasympathetic, okay? The effectors are different here. So now it's not going to be skeletal muscle because this is not in our control. These are not things that we can directly control, like, oh, I want to move my stomach muscle right now to the left. I can't do that, right? It's got to be something that does it on its own, right? Okay, so what we are doing, the effectors in this division and this division are going to be smooth muscle, cardiac muscle, glands. Okay, these glands are going to be mostly exocrine glands, but some endocrine glands as well. One thing though, with the sympathetic division, you have to remember this. No sweat glands. No sweat glands. Okay? There are neurotransmitters in both of these systems. Okay, so both of these systems, both of these divisions have neurotransmitters. Here's the trick. The parasympathetic will only be cholinergic. What that means is it's only going to deal with acetylcholine. So what I mean by that is, this is more physio, but they're types of receptors. So they're going to be muscarinic, and there's like muscarinic receptors and nicotinic receptors. Too much information, you don't need it. But for your class, you do need to know that this is acetylcholine. Acetylcholine will be both in the pre and post, will be acetylcholine. Okay? And then here, hold on. Let me clean this up a little bit. So in the pre and the post, here we're going to have long pre and short post. Okay? And then the effectors are the same in both. Smooth muscle, cardiac muscle, glands. Smooth muscles, cardiac muscles, glands. These are the effectors. These are what the neurons are going to do. They're either going to trigger a smooth muscle, they're going to do a cardiac muscle, or they're going to do a gland. technically they can do another neuron. So sometimes it's a chain, right? Sometimes it's got to go from this neuron to 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 this neuron, all the way until we get to this gland. All the way until we get to this smooth muscle. But the gist is the same. Smooth muscle, cardiac muscle, glands will be the autonomic nervous system. The somatic division is, which we already said, skeletal muscle. Okay. The neurotransmitters in the parasympathetic division will be acetylcholine. They're both acetylcholine, which makes the parasympathetic cholinergic. Cholinergic. Whereas this one is a little bit, the sympathetic division is a little bit more complicated. It's got both. It's got acetylcholine as well, but in the post, it's got norepinephrine. It's got norepinephrine. And this makes sense. When we thought, remember when we were learning about the kidneys and we were talking about epinephrine and norepinephrine? Remember, we learned about the adrenal glands? What does that sound like to you? Adrenaline, right? Okay. Well, the sympathetic division is fight, flight, or fright. The parasympathetic division is always going to be rest, digest, or repose. I think Lonnie just teach you rest and digest, fight or flight. Doesn't matter. I'll rememorize it. You need to know these things. So the sympathetic division is going to do things like it's going to dilate your pupils, right? It's going to constrict your arteries and veins. It's going to increase your blood pressure, right? It's going to increase your heart rate. If you have to urinate, it's going to turn that off because right now you're in fight, flight, or fright mode. Like you got to get out of there, or you got to make a decision. So certain things in your body are literally going to start shifting to increase. So you're going to get this rush of norepinephrine, this rush of adrenaline. In physio, you need to know this a lot more in detail. But this chart, if you memorize this chart now, this will be one of your word problems, I guarantee it. So if you can literally put this on paper for your word problem, this is probably your whole 5 points on that. You just have to be able to understand which one's which. Okay? The pre is short in the sympathetic, the post is long. You need to know that. T1 and L2, you need to know that. For multiple choices, she might just say this one is located in the T1 through L2. You need to know, okay, sympathetic. This one involves cranial nerve number 9. Oh, that's the cranial sacral. That's got to be the parasympathetic. You need to know these for multiple choice like that. Because that's, if I remember correctly, I think there's a good portion of your exam on this. Okay? So, again, if you see acetylcholine, the nervous system can be cholinergic. If you see norepinephrine, epinephrine, anything like that, it's called adrenergic. Adrenergic. Again, this is more physio stuff, but I'd rather give it to you now so that way you have it going forward. Okay, so we're going to talk a little bit more about this afferent and efferent. This idea of afferent and efferent. This is kind of complicated, and I remember the last class that I tutored had a little bit of an issue with it, so, and forgive me, as I say always, I'm a terrible drawer, but I'll do the best I can. Okay, so the way I do this is this. You're fine. I'm not even worried about it. Thank you. Or like, I feel like my 5th graders would be laughing and talking crap right now. So I'm totally used to it. I have thick skin when it comes to that. If you guys want to speak the truth, I'm all for it. Lonnie came in here, she's like, what the hell is this? Okay. All right. So the way I do this is with the bee sting, okay, because this is how I memorized it. Bee lands on your arm. Holy shit, got a bee on my arm, right? Freaking out. Got to do something about it. So what happens is, what happens first? We have afferent, efferent, right? Which one starts it all? Afferent, right? We got to get this information going on, right? So bees on my arm, I got to get that information to my brain. So it's going to travel this way. So the information comes in here with the afferent division. It's traveling, making its way through here. Here we have a bulge. This will be the DRG. Anywhere you got a bulge, it's going to be ganglia, right? Remember I said that? Anywhere it's like a bulge, a bundle, it's ganglia. So this will be the dorsal root ganglia. There is no ventral root ganglia. Notice the ventral roots on both sides, they're just slender. Okay? I don't know how well you guys can see, but I also have, you want to see it like how you might get it on your practicum. Any magnets. All right, well, I'll just try and explain. Okay, so information comes in here, right? It's going to start right here through the what? The dorsal root ganglia, right? Okay? And then it's going to go to the, after the dorsal root ganglia, which is right here, it's going to go here, to the dorsal root, right? Dorsal root. To the, where you would have like thin little fibers coming off. These would be the rootlets. Rootlets. So it's going to go DRG, dorsal root ganglia, dorsal root, rootlets. Then it's going to be in the spinal column. Okay? Now, in this particular, for the bee sting, we're talking about a somatic response. Because what am I going to do if I have a bee on my forearm? I'm going to smack it away, right? So what has to happen first, you have these sections. Okay? The way to identify it for your practicum is the ones that look like sharp horns is always going to be posterior. So if you're looking at it, I don't care if she has it upside down, whatever, if you see the two sharp points, you know that's the posterior portion. Okay, so you're looking at, okay, that's the posterior portion of the spinal column. Okay? There is another way. I think there's like a big divide here in the ventral section. It's kind of like this, but sometimes it's not that noticeable. Okay, whereas here you'll have like some sort of like a little crease. Okay? But here, what I want you guys to remember is the posterior does both. The posterior does both. So you kind of have to divide the posterior in half. Okay, so you divide it in half. The uppermost portion, or the backmost portion, I should say, this area I'm coloring in right here. Actually, let me use a different color, right? Keep it easy. Let's say this area right here, and this area right here, right? Okay? These are going to be posterior. These are your posterior gray horns. These are your posterior cell bodies. Okay? The outermost portion is going to be somatic. So what that means is once this information comes here, it's going to synapse there, because we're talking about a bee sting. We're talking about a somatic response. So we need to synapse here. So what happens is it synapses there initially. Did she talk to you about like an interneuron? Did she mention interneuron at all? Okay, there's another player involved. Unless it's a reflex where everything's going to involve two synapses, right? Two synapses. Well, a knee-jerk reaction, for example, would be like one synapse. Okay, so you would just do that, right? And it doesn't involve the brain. It's like, forget you, I'm bypassing that, I don't need this. It just does it on its own. That's one synapse. Everywhere else, you're going to have an interneuron, okay? The interneuron will be in between. So basically, the way I look at the interneuron is it's what's taking it up. It's like the bellboy that's going to open the elevator for you, okay? So what it does is it synapses here because it's a somatic response. Then it takes this interneuron and it's going to go up, okay? The white columns is where it's going to travel up or it's going to travel down. Up or down, okay? Within the gray body, that's where we're synapsing. Does that make sense? That's where we're gonna make our synapses. My boss is calling. Hold on. Hey, I'm in tutoring right now. No. It just, if it's about to drink, whatever. Oh, what's up? I guess. Yeah, can I still come to site as well, like normal? Transferring, okay, all right. Yeah, we'll talk about it when I get there. I gotta get back to this. All right, come back. Oh, no, sorry, I guess I'm going to a different site today. All right, so it takes this interneuron and then it's got to travel up, okay? For this reason it's traveling up is because what did I tell you is like the command center? The hypothalamus, right? It's got to go up there and it's got to make certain decisions, right? It goes to what we call a control center, okay? When it reaches this control center, it basically is figuring out, okay, now what are we going to do about this? Now we're getting the information, we're processing that information, now we got to send it down. So basically it's gone to like a control center, getting information for what to do next. Does that make sense? Like, it's synapses first for what it is, it's somatic, okay? So it has to be this back portion. So because it's somatic, it's the backmost portion, okay? Once it does that, it then takes the interneuron to go up. Then it goes to a control center, whatever the integrating center is, whatever that control center is, whether it's the hypothalamus, whether it's the pons, whatever the situation calls for. For this, it would probably be the hypothalamus, okay? It goes up there, and it gets that information, right? Now it's got to come back down. When it travels down, it's going to travel down the anterior. It's going to travel down the anterior white column, right? Okay, so it travels up the posterior white column, and it travels down the anterior white column. Does that make sense? Okay, so now it's traveling down the anterior white column. So now we have our afferent and we're done. Afferent's done. Now we're on efferent.
So afferent ends when it gets back to the...
When it gets back down to the spinal column where it needs to now synapse again. So now it's got to figure out what it is doing. So what are we going to do about it?
Is it going to be in the same part of the spinal cord?
No. Good question. No. So now it depends what is the response. In this particular equation, or what we're looking at situation, we are still dealing with a somatic response, okay? This is where it gets a little tricky. Like if it's something to do with osmotic pressure, if it's something to do with regulating, something like a glucose level, something that you have no control of, it's going to be a visceral response, okay? It's going to be an autonomic response. If it's something you have control of, like, okay, I need to run out of here because I smell smoke, right? Does that make sense? It varies in the situation. So you need to understand the difference between visceral and somatic. When I say visceral, it's autonomic. Okay? Now, here in the anterior is a little bit different. You have a posterior gray horn, you have a lateral gray horn, and you have an anterior gray horn, correct? Correct? You got that for your I believe you should have that for your practicum, right? Okay, so your lateral is going to be like this portion right here and this portion right here. Okay? Lateral will always be a visceral response. Visceral. It's a visceral response. This portion right here, this whole front portion, will be a somatic response. So here we have somatic, here we have visceral, and again, remember these divide into two. This is the receiving of the information. So the top portion, remember I said the backmost portion was what? Somatic, right? That's the somatic information. Sensory, this is sensory information coming in. So somatic sensory information coming in, this will be visceral. So if it synapses here or here, your body's detected something somatic, or something visceral, something visceral. So that would be like, okay, like I'm saying, something's off with your osmotic pressure, something's off with your blood pressure, and your body's reacting to that. Okay, does that make sense? Whereas here, it's like, oh, I have a bee, something landed on me, or I got something physical happening to me, right? Something I got to do something about. I got something in my eye, I got to do something about it, right? Okay? That's what these are. That's the information coming in. This is the information coming out, okay? So if it was a detection of osmotic pressure, your response would be visceral every single time, because you have no control over that. You got to get ADH, remember the antidiuretic hormone? We got to get that down there to help relieve whatever, we got to like balance out what's going wrong with the kidney. Why is that? So maybe if it's something to do with the afferent arteriole that's entering in, we got to do something to constrict it, or to increase the blood pressure, or to decrease it. Okay? So we're going to need a hormone to play. Okay? Does that make sense? Okay, but here, if it's a bee and we just want to swat it away, it's going to synapse here or here. Okay? I know it's confusing, but do you kind of like get it? Do you have any questions? Raise your hand if you have a question on this.
Yeah, where did you say it's going to synapse?
It depends on the situation. So we're talking about a bee state. So a bee lands on your arm. This information travels up, right? It's going to travel up it starts at the ventral ramus, right? And then it's going to make its way to the dorsal root ganglia, to the dorsal root, to the dorsal rootlet. And now since we have a somatic response, it's going to synapse where? This backmost portion, right? This backmost portion. Okay? Then it's going to take the interneuron and it's going to travel up the posterior white column. It's going to travel up the posterior white column to the brain, to the control center, getting the information to what are we going to do next.
The hypothalamus?
Yeah, I mean, it could be. The control center could be the hypothalamus, just depending on the situation. It could be a lot of different things. Okay? Okay? I just said the hypothalamus because it literally controls the most things. So chances are it's something like that. Does that make sense? It's just something that you can relate to. Okay, now it gets that response, it gets that information that what it's going to do about it. Now it travels down the anterior white column back here. So now it's got to synapse into either a visceral or a somatic motor response. A visceral or somatic motor response. The reason I say motor is because it's something we're going to do about it. Okay? Visceral will be something out of our control, but we just want to smack the bee away, so it's going to synapse here. Okay? And that's your two synapses.
Where did you say the interneuron was?
The interneuron is right after the initial synapse. So once it synapses between, whether it's a ventral response, in the posterior section, once it synapses the first time, it's going to take that interneuron up to the white posterior column of the brain. Okay?
So there's no other interneuron?
No, because like the way it works essentially is you're going to have your synapse, interneuron synapse. Does that make sense? So like the interneuron's kind of in between. Literally why it's called the interneuron. It's just in between. Okay? And the only one that bypasses that is a knee-jerk reaction. It's a single reflex. It cuts off the CNS. It doesn't involve the brain in any way. Okay? So it's like the knee-jerk reaction. Okay? All right. Once does this, now it's got to travel out. So when it travels out, it's going to travel out the ventral rootlets to the ventral root. And then once it does that, this is where it gets a little bit different. It depends. If it is a somatic response, then it's just going to continue out the ventral ramus and to the, what's after that? What's after the ventral ramus? To the ventral root, to the, spinal nerve, okay, out to the spinal nerve to what then?
Dorsal root
No, the dorsal root ganglia is when it's incoming. Dorsal root ganglia will only be incoming, okay?
Ventral ramus.
So it takes the ventral ramus, yes, okay? Spinal nerve to the ventral ramus. Then you have the rami communicantes, okay? The rami communicantes, if it's is where it's going to travel down to the sympathetic chain ganglia, is going to be if it's a visceral response. Visceral.
So after the ventral ramus, what do you?
After the ventral ramus, I think it just goes down it goes to the sympathetic chain ganglia. Okay? If it's a visceral response, it takes the rami communicantes.
Can you repeat that?
If it's a visceral response, it takes the rami communicantes.
And it's somatic.
If it's a somatic, then it just goes, it bypasses rami communicantes to the sympathetic chain gang. So it'll go from ventral ramus to, it'll take the ventral root,
Or sympathetic.
ventral rootlets to the ventral root to the ventral ramus to the sympathetic chain ganglia.
So where's the spinal nerve?
The spinal nerve is this area right here, where they kind of come together. So this area right here, that's your spinal nerve.
So
When the two converge, so when you have the dorsal root ganglia and the ventral root, when they come together and they form kind of like a bigger body, that area, that's your spinal nerve. So if you're looking at your practicum, the spinal nerve will be where they come together. Okay? The bigger thing that I want you guys to understand is this. Because this is going to be like questions on your exam. She'll give you an example like, I don't know, like she'll say your heart rate has increased due to something. Where did it synapse? Where was the first synapse? So if it's a heart rate increase, then you need to know, okay, it's ventral, so it's going to be, you need to know, if you're looking at a picture on your exam, you need to know, okay, this is where it synapsed. Okay? Because she'll have, like, you'll be looking at this picture and, like, you know, the ones where she has, like, this and this kind of pointed, you know, you need to be able to know which one's A, which one's B, which one's C, right? That's what she's going to need you to know. So, I have a picture, it's messy, but it's how I memorized it. I suggest each one of you just take a picture of it, kind of study it. This helps.
no, will she give us a pathway?
Okay. Pathway, so the word problems for this one are going to be, for sure, this. For sure, I would be very surprised if that was not on there.
How would
She
ask
could
that?
give you one, like a pathway, which you would need to know, like, okay, with the dura mater, right, the arachnoid mater, the pia mater, right, and what's kind of in between each. Okay? There could be definitely something like that. You know, it's fair game,
No,
sure.
but what about that?
Yeah, like, I mean, if
How would she ask this?
she would say, like, compare and contrast the sympathetic division to the parasympathetic division. This is how you got to do it. Because this is what she's going to look for. And this you're going to need for physio. You're going to need it. Because in physio, you're responsible for learning all the neurotransmitters, not just the hormones. So you got to, this helps. I would say just knowing this, having this background now, is going to help you in the long run.
So for this one here, the first one, posterior
So like, let me just ask some questions and see. What were you saying? I'm sorry, go ahead.
About the synapse, the first and second?
Yeah, so there's going to be a first synapse, right? And that first synapse will take place in the which great horn? Posterior great horn, because that's where the afferent information is coming in. Okay? The second one is going to be in the efferent. Okay? But in between the two, you're going to have an interneuron. Okay? And the interneuron, the way I look at the interneuron is kind of like the bellboy. It's opening the elevator door for you to go up. And then to come back down.
This stuff is like,
I know, it's a lot. It's complicated. It's complex. It's tough. I wish I could have helped you guys last week too, because I like to give you guys some physio background on that too. So like I know you had to do obviously all your cranial nerves, olfactory, optic, oculomotor, trochlear, trigeminal, abducens, facial, those, right? We went through all those, right? Well, in physio, you need to know which ones are sensory and which ones are motor, and what do they do. So I was going to...
it talks about that in our book too.
Yeah, so in physio, you're responsible to know what each one is kind of doing. A lot of them control the face. I think there's like 6 of them that do different things to do with the facial muscles, just because there's so much going on. Or eye movement. A lot of them do eye movement. There's like 4 of them that do it. Things like that. So, did you guys get any mnemonics? Like on occasion, our trusty truck acts funny, very good vehicle anyhow?
We have some weird ones.
Okay. Food for thought, you might want to just memorize some say Mary money, but my brother says big brains matter most, because that tells you which ones are sensory and which ones are motor and which ones are both.
What?
Yeah. It's just,
S, N, and B. Like,
Do it again.
so some say Mary money, but my brother says big brains matter most.
oh, and that's
That tells
order.
you which ones are sensory, which ones are motor, and which ones are both. Yeah, I mean, I know it's not relevant for the chapter you're doing now, so it's just, it is important.
Okay, I was like,
Yeah.
They gave you like tests. So, what did you have for your short answer? Do you have your test with them?
Yeah, that's what I had.
Oh.
That's why I put it up there.
And she's only got pictures, so we can draw.
Okay, so yeah, we'll do
So please draw that chart because, that's basically what we
Memorize this chart through and through, because there's going to be a ton of multiple choice questions, and if you have the chart memorized, you know which ones are which, because the people that don't do well on this exam are the people that they get things mixed up, and they're like, oh crap, that was actually the parasympathetic division, not the sympathetic division. And if you mix them up, you're going to get them wrong. So memorizing the chart is the key to your success for this test. If you memorize that chart, and you should really just have that chart pretty solid. Like, I still have it pretty solid. Okay? For the cranial nerves, you might want to just make note of this, if going back to them if you wanted to. Some say marry money, but my brother says big brains matter most. This gives you the order of which ones are which. So, ocular motor, or olfactory, smell, it's a sense, right? Optic, vision, right? It's a sense we receive, right? Okay. Ocular motor, it's going to be a movement, eye movement. Specifically, it's kind of like the lateral and diagonal eye movement. Okay. Why am I screwing up right now? Trochlear, thank you. Trochlear, again, this is going to be eye movement, lateral eye movement. Okay? And then you have the trigeminal. This does a lot of different things. This one is the big one. It's going to do eye movement, but it's also going to do, I forget off the top of my head, but it does both. Okay? And then you have abducens, right? Yeah. Abducens. So this one's going to be a motor response. This is facial, kind of leading up to facial. It does some facial movement. It does some eye movement still. Facial, this is going to be both. Just think about that. If you have something land on your face, right, you sense something is on your face, right? But at the same time, your eye might move or your face will move, right? So it's going to do both, right? Okay, cranial nerve number 8. It's the vestibular cochlear, right? Yeah?
That's the ear.
That's the ear, but it does,
Wait,
6, 7, 8. 8, sorry. 8. Vestibular cochlear. Okay, so this one is going to be a sense, right? It does a couple things. It's going to, it's split into 2. So you're going to have the cochlear nerve, and you're going to have the vestibule portion. The vestibule is all going to be for, it's like equilibrium, you know, like what keeps me from falling over, you know, it's what keeps me kind of grounded, okay? And then you have the cochlear portion. This is where you're going to have that hearing, right? This is the hearing nerve, okay? So this is the portion that's responsible for receiving that information of sound, right? Okay, 9, we should have the glossopharyngeal, right? Glossopharyngeal, okay? This is going to do 2 things too, so it does both. And then 10 is going to be vagus, right? It's the only X-rated one, so of course it's got to be 10 because vagus is X-rated. Okay, this one does both. Okay, and then remind me, or on Friday I'll bring my physio sheet so we can just kind of give you what specifically one thing each one that they do. Okay, and then accessory motor is going to be motor, and then what is the last one? Hypoglossal. It's going to be motor. Okay, so just kind of memorize this now because you'll need it for physio. There's a chapter in which you just need to know, okay, this one is a motor response, this one is a sensory response, this one is both. And this is what it's talking about. Like it's which one is only there to sense stuff and which one is actually doing things about it. Okay. For the practicum, I think you have the eye and the ear, right, this week?
Yes.
Okay. The eye and the ear are pretty easy. They're not too bad, but that's another pathway question you could definitely get. Give me the pathway, track the pathway of vision. Definitely could have that question on your exam. Fair game. You know, you track the pathway of light as it comes through your eye. First, you're getting it from the outside, then you're going through what, and then through what, and then through what. And I do have that one somewhere, and I'll have that for Friday, but I'm running out of time. But yeah, track the pathway of light. You gotta have that one down. That one definitely could be up there. Knowing that chart could be up there. There might be the pathway for hearing, but I really don't see that one on as a. I don't think she'll throw that. She might. Fair game. So like those things, you just need to know. Okay, well, it's going to start from the auricle of the pinna. It's going to go into the auditory tube, right, in between. Then you're going to hit that tympanic membrane. You know, just things like that. Once you hit that, once the vibration hits the tympanic membrane, it's what kind of sets the little bones into effect. You need to know that it's MIS. It's always going to be MIS, M-I-S, Malleus Incus Stapes. Okay, MIS. And those are kind of what are causing the movement inside your ear that are going to get the. Then it's going to hit into the oval window and the vestibule. But then it really depends. Is she asking for the pathway? This is where it splits. Is she asking for the pathway of hearing, or is she asking for the pathway of like something? Is something just penetrating through your ear, right, or something like that, right? It depends what the question is. If it's about hearing, then you know you're not going to be dealing with the vestibule. You're going to be dealing with the cochlea. Okay, and then that's when the cochlea is going to have the 3. She has it like, I think, a scala vestibule. I was like, always forget that. I was always like, no, I'm going to go with vestibular duct, tympanic duct, cochlear duct. Cochlear duct's in the middle, vestibular duct is on top, and the tympanic duct is on the bottom. So just understand that. In that way, it goes, it's the VCT. The VCT. Okay? Vestibular duct on top, cochlear duct in the middle, and the tympanic duct on the bottom, the VCT. Okay? Within that C portion, that's where you're going to have the organ of Corti. That's literally what's responsible for the hearing portion. That's where you're going to have the nerve fibers and all that kind of stuff. Okay? Sorry, I know I talk fast. I'm just running out of time. Friday, I'll go over it in a lot more detail. It's not too bad. She's going to give you the muscles on Friday. The muscles, she says they're easy. The spelling part can be a challenge. You know, there's some tricky ones. Corrugator supercilia, or corrugator supercilii. You have to remember it's got an extra I, and the way I remember this with corrugator, I always thought you make a funny face like this, or some kind of face like this, you're crunching your eyebrows together. It's going to be, oh, that's a silly face, kind of. You making like a silly face? Okay, well, that's corrugator supercilii. Okay? And then, anytime you hear the word frontalis, we already know frontalis is going to be here. So, like, because of our frontal bone, right? Okay, so frontalis, just think entire. So it's going to go from here all the way to here. Occipital frontalis will be from here to here. Okay? And then anywhere you hear the word orbicularis, it's going to be round, like an orbit. Orbicularis will be round, and there's two of them. There's orbicularis oculi. These are the round muscles around our eyes, which makes sense when we're talking about facial and all the different things. I mean, our muscles can do so many different things. Our face can respond and make so many different faces, right? This is how. So orbicularis oculi will be around the eye. Orbicularis oris will be around the mouth. Okay? Buccinator, just remember it as you're sucking in your cheese. It's going to be a really, really thin muscle in between everything else. And then zygomaticus major, it looks like a tiny bridge. It's like a diagonal bridge. And I mean, that's how you remember them. And zygomaticus major is for smiling. It's what makes you smile. So when you smile, it pulls the lips up. And it will make sense when you see it. On Friday, when you see it, it will make a whole lot of sense. Risorius, it literally goes to the side of the lips. So like, zygomaticus major is diagonal, risorius is right across. Okay? Mentalis, chin, mental. Okay? So if you see one that's like this, mental. Plasma is this. Plasma, it'll be a picture of this on your practicum. Somebody doing that. These are the muscles in your neck responsible for that. Okay?
Pictures, not the.
She'll have pictures. Masseter. Masseter is pretty big. It's a big muscle that goes like this. It's for jaw, chomping. Okay? I think the masseter elevates your jaw, closes your mouth. Okay?
So these will be pictures, not models?
Most of them will be both. They're going to be both.
Pictures
Just
of the actual-
plasma will be a picture, guaranteed. It'll be like it'll be a black and white picture of somebody going like this. Promise you. If you get it, that's what it'll be. Corrugator supercilia, same. You're not going to get it like here on the model. It's going to be a picture of like a funny face where the eyebrows are going like this. Okay. Temporalis is just going to be on the temple. Okay, so the masseter kind of will connect to the temporalis. Digastric, easy to remember, there's two of them. They kind of like go like this. Okay, you'll see them.
She'll be pointing just to one?
Yeah, it would just be the one, but you'll know they're together. You'll see it on the model on Friday. The other ones is where it gets a little bit harder. The mylohyoid, the geniohyoid, stylohyoid, sternohyoid. Those we'll have to look at specifically on Friday. Sorry guys, I know I'm running out of time.